what is the remainder when the positive integer x is divided by 6? So if we are dividing by 6, the options we have for our remainder are just 0, 1, 2, 3, 4, and 5. And so our remainder always has to be less than our divisor, what we're dividing by. um, because after we get to 5, what remainders are patterns, right? So our pattern just resets back to 0, and then we have the pattern all over again. And so with that in mind, we still need to know more about x. Let's look at our statements. When x is divided by 2, the remainder is 1. When x is divided by 3, the remainder is 0. So I love it when I see things like this, because the problem I have with remainders, and I think a lot of people have, is how do you translate statements or involving remainders? Because remainders aren't normal algebra. They don't follow the rules of normal algebra. And so you have to be careful when writing algebraic expressions for statements involving remainders, because they have to somehow take into account this restriction where your remainder always has to be less than the thing you are dividing by. So you got to be careful sometimes, setting up equations involving remainders, but also manipulating equations involving remainders. But when I see this pattern here, when something is divided by something, the remainder is something, I always know I can translate that because it's just a pattern that I recognize. And so sometimes it will say something like this, or sometimes it will say when x is divided by 2, the quotient is y or something, and the remainder is 1. Same thing. And so I can think of this when x is divided by 2, the remainder is 1. That is telling me x is equal to 2 times y, where y is just some quotient or some integer multiplier, plus 1. And then this guy here, when x is divided by 3, the remainder is 0. That's telling me x is equal to 3 times z. So in this case, z is the same thing as y. It's just an integer multiplier, but it's not necessarily equal to y. So I don't want to use the same variable that I use here. So I'll just call this z plus 0. And so what is this just telling me? This is telling me x is a multiple of 3. So 3, 6, 9, 12, 15, 18, 21, etc. What is this guy saying? So here we actually might have to, if we could just find two numbers, we can see the pattern. So if y is equal to 1, x is equal to 3. If y is equal to 2, x is going to be equal to 5, and so it's going to go up by 2 every time. And so if both of these equations must be true, we can only choose values for x that appear in both of our lists. And so let's pick those out. 15 does, 21 does. And so then let's find values when these numbers are divided by 6. So when 3 is divided by 6, that would be 0, remainder 3. When 9 is divided by 6, that is 1, remainder 3. 15 divided by 6 is 2, remainder 3. So you might be noticing it looks like a remainder here is always 3, and 21 divided by 6 is 3, remainder 3. So a remainder, according to this statement, looks like it's always got to be 3, and that is sufficient. So I would guess the first statement gives us 2 equations, and that was sufficient. This one only gives us 1, so if I had 2 seconds left on my test and I had to guess, I would probably guess the second statement is not sufficient, but I'm not sure, so let's see. So when x is divided by 12, the remainder is 3. So we can write this as x is equal to 12. I already used y and z, so what should I call this? I'll just say a. 12a plus 3. And so if a is equal to 1, we actually want to find what. So what can x be? If a is equal to 1, x can be 15. If a is equal to 2, it's equal to 27. So we're going up by 12 each time. 15, 27, 39, 40, 51. 53. So in each of these cases, what is the remainder when x is divided by 6? So 15 divided by 6 is 2 remainder 3. 27 divided by 6 is 4 remainder 3. 39 divided by 6 should be 6. Yeah, 39 divided by 6 is 6 remainder 3. So it looks like this actually is going to be sufficient. 51 divided by 6 is what? 9 times 6 is 54, 8 remainder 3. So it looks like this one's also sufficient to say our remainder will always be 3, and therefore D is our answer. So they were trying to trick us into thinking it would be A. It was D.